Okay, so today we are going to cover section 4. Section 4, we're going to be breaking it up into 4 different days. So this is actually P4A, and then we'll do B, C, and D. So this is day 1 of factoring. So we're first going to start out nice and easy by just factoring out a greatest common factor. So once you first look at your polynomial, you're going to look for the greatest common factor of the coefficients and of the variables. So my greatest common factor here between 6 and 4 is going to be 2, and my greatest common factor of the variables is just an x. They both have an x in common. So what I like to do, and maybe you can do this at the beginning, is I like to write the greatest common factor underneath each of my terms. Now you don't have to show this, but it gives me a visual so I can see what I'm dividing by. So then what I'm going to do is take that GCF, I'm going to write it outside of my parentheses, and then on the inside of the parentheses is going to be the answer that you get after you divide each term. So I'm going to divide 6x cubed by 2x, and that's going to give me 3x squared. Remember, you subtract the variable exponents when you divide. Then next, I'm going to divide 4x by 2x, and that's going to give me 2. X to the first divided by x to the first is just 1, so the x's are gone. And this is going to be your simplified or factored binomial. Now, remember what you can do is you can always distribute it back. If I distribute this back, it should go back to my original problem. Now, let's say you picked a GCF and it wasn't big enough. It wasn't the greatest. Chances are what'll be left in the parentheses is something that could still be factored further. So you should always look for the greatest common factor. If there's still common factors left in the parentheses, then you need to go back and you need to look for a bigger common factor. All right, let's try some more examples. Again, we're only factoring out the greatest common factor. Now, when you're given a trinomial and they're asking you to find a GCF, the GCF must be in every single term. So I need to see what kind of factor is in common to the negative 4x squared, the 12x, and the negative 16. And I can see that there's no variables in common, but I can pull out a greatest common factor of negative 4. Now, again, I'm going to try to leave that leading coefficient positive. In this particular case, you could pull out, I would always try whenever I'm going to get a trinomial remaining, I always try to make my leading coefficient positive. So I'm going to go ahead and divide everything by negative 4. That's going to be my GCF. Again, I write the GCF outside of the parentheses. And now the answer to the division of each term goes inside the parentheses. So this will give me a positive x squared, a negative 3x, and a positive 4. Now, if this remaining trinomial that was in the parentheses could be factored further, I would keep going. But I cannot factor that, so I'm finished. Always, whenever you're factoring any type of polynomial, you should always look for a greatest common factor first. Let's try the next one. This time, yes?
What determines if the greatest common factor is negative or positive?
So whenever I'm going to do a problem like this, and if I know that this is going to be a factored trinomial, I would pull out a negative 4. In this particular case, you could have also pulled out a positive 4, and I would still give you credit on this one. But whenever I know I'm going to get a trinomial that I got to keep going with, I always try to make sure that this x squared term is positive. So that's when I would pull out a negative. Does that make sense? All right, everybody good? All right, the next one, my greatest common factor of the coefficients is going to be 3, and my variable that's in common is x. So I'm going to divide each one of these by a 3x. And now the GCF, or the greatest common factor, goes outside of the parentheses, and then the answer to the division of each term goes inside. So 3x cubed divided by 3x is just x squared. 6x squared divided by 3x is 2x. And then 9x divided by 3x is just 3. And again, if this polynomial could be factored further, I would keep going. But this one is prime. I do not go any further here. Now, number 3, your greatest common factor does not have to be a monomial. It could be a binomial. And if you notice here, the factor that's in common, this is a term and this is a term, and what they both have in common is the x minus 2. So that is going to be my GCF here. It can be a binomial. So I'm going to divide this one by x minus 2 and this one by x minus 2. That's my GCF that's going to go on the outside. And again, this is gone. This becomes 1s. So I'm now left with 2x. And over here, I'm left with the plus 3. And I'm done. This is sort of looking like the factor by grouping technique that we could use for factoring polynomials. For the next one, same thing, because if you remember, this x plus 3 squared is really this. So you can see that they both have in common the x plus 3. That is my GCF. And then that simplifies, and I'm left with a single x plus 3. And then out of here, I'm left with the minus 4. Now, this might have been something that you may not have seen in your Algebra 1. You definitely should have seen the factoring out the monomial. Now, this one I'm still not finished because in that second parentheses, I've got like terms here that I can combine. So x plus 3, and then 3 minus 4 gives me negative 1. And now I'm done. So that is examples of factoring out a greatest common factor that's either a monomial or a binomial. Next, we're going to talk about the difference of two squares. Yes?
How did you get the x plus 3 and then
The minus 4?
3 minus 4?
Okay, so what I did was, so again, just to show you again, this problem, this right here is really x plus 3 times x plus 3, the x plus 3 squared. And then over here, I'm just leaving, or actually, 4x plus 3. All right, so what I'm looking for is what do they both have in common? And they both have an x plus 3. That's my greatest common factor. And remember, what we did up top there was we were dividing all of the terms by that GCF. So when I divide my first term, this divided by this is just 1. So then I'm left on this term with just the x plus 3. Then over here, when I divide this term, the x plus 3's cancel, and then I'm just left with the negative 4. And that's where I got that minus 4. And then now I just combine these two like terms, and that's how I got x minus 1, and then just drop the GCF down. That better?
Yes.
Okay. So again, you might not have seen this in your Algebra 1 class, so this will be something that you might want to practice some more. So the difference of two squares is when the two terms of a binomial are perfect squares. And what's important here is that you recognize that there's a minus sign in between the perfect squares. hence the name, the difference of two squares. So in order to do this, all we need to do is square root the first and the last terms. One of the parentheses will get a plus sign and one's going to get a minus sign. So let's go ahead and let's try this example that's here. So I have my x squared minus 4. X squared is a perfect square, and so is 4. Notice in between them is the minus sign. If this were a plus sign, if it were the sum, I would not be able to factor this. So then what I'm going to do is square root the first term, square root the last term. The square root of x squared is x, and I'm going to write that right here and right here. And then I'm going to square root the 4, and that's what I'm going to place right here. And one gets a plus sign, one gets a minus sign. It doesn't matter if I put the minus sign first and the plus sign second. Either way. You can now FOIL this to check your answer. So if I FOIL this, first, outside, inside, and last, notice when you combine these two, they're gone, and it does go back to the original problem, so you factored it correctly. So whenever you see a binomial and both of the numbers in your binomial are perfect squares and it's got a subtraction sign, the trick is just to square root them and then put one with an addition sign and one with a subtraction sign. And always remember, on any of these foiling questions or multiplying these, after it's factored, you can multiply it back. If it doesn't go back to your original problem, you've done something wrong. Let's try some examples. So for number 5, whenever you're factoring, whenever you see the instructions factor, you should always look to see, is there a greatest common factor that I can pull out first? So for this first question, there is no GCF. And then if I look at my numbers, I can recognize that 9x squared is a perfect square, and so is 49. So in order to solve this, I'm going to square root the 9x squared and square root the 49. And then I'm going to set up my binomials. So the answer to the square root of 9x squared will go here, and then the 49 will go here. One is going to have a plus sign, one's going to have a minus. Square root of 9x squared is going to be 3x. So I put both 3x's there. And then the square root of 49 is 7. And I'm done. And again, you can FOIL it and make sure it goes back. And it will. Now, when I would teach this to my Algebra 1 class, I would highly recommend that they memorize the perfect squares up to 20. That way, when you get a problem and you want to determine if it's a perfect square, if you've memorized those, it makes it a lot easier. Now, honestly, you should know up to 12 from 3rd grade when you learned your times tables. So then it would be just a matter of memorizing 13 to 20. Fun fact with 13 and 14 is 13 squared, or the square root of 13, well, so the square root of 169 is 13. And then if I switch up the numbers, that's 14 squared. So as long as you know one of them and then realize you just switch the numbers to get the one after that, a quick little way to remember that. Another fun fact is everybody knows that 12 times 12, or 12 squared, is 144. But if I do 21 squared and write the 12 backwards, this answer is actually 441, and you write the number backwards. So just some little fun facts with numbers. All right, let's keep going with our factoring. So next one, again, look for a GCF. There's nothing that divides into either of these. So what I'm going to do now is double check that 36 is a perfect square and 49, which they both are. So again, I will square root the 36, square root the 49, and then again, fill in my binomials. So again, the first terms, square roots go in the first spots, and then the second. So the square root of 36x squared is going to be 6x. And the square root of 49y squared is going to be 7y. One gets a plus sign, one gets a minus. If you would have rather made the first binomial the subtraction, it works as well. The placement of the signs of the plus minus signs does not matter. Now the next one, you might look at it and say, oh, those are both perfect squares. Let me show you what would have happened, what it's going to look like if we don't factor a GCF out. This one, I need to factor a GCF out first. Let me do it the appropriate way first, and then I'm going to show you the wrong way. So this one first has a GCF. I can divide both of these by 4, and then I'm left with x squared minus 25. Now, this is sort of leading us into when we're going to get questions where it's going to say factor completely. Once you pull out a GCF, you need to look at this and decide, can I keep going? And again, this is still the difference of two squares, so I have to keep going. So I'm going to square root the x squared, square root the 25. So now, don't forget about that GCF. It needs to stay in front. And then this is going to give me x. This is going to give me 5. And then the same thing over here. But I'm going to switch up the signs. And now instead of, it'll be a plus sign and a minus sign. So x and then the 5. And that would be your final answer. Now, let's say instead you recognize this and you thought, oh, 4x squared is a perfect square. And so is 100. If all you did was square root this and square root this, watch what your binomials are going to look like. It's going to end up being 2x, and this will be a 10. Notice in this binomial, you still have a GCF that you could have pulled out. So notice I could still divide both of these by 2. So I know from the beginning I should have pulled out a GCF, so I need to go back and restart. So if after you factor something, if there's still another GCF hiding in here that you could have divided by to make it smaller, start over again and look for a GCF. And in this case, it was the 4. The last one, first glance, you're saying, oh, 25x squared is a perfect square, so is 36. But remember, there is no such thing as the sum of two squares. So this one, you can't factor. So if this were a quiz question or a test question, you would just rewrite the problem. Or in some books, they taught you to write the word prime. Or you could also write cannot factor. So if something is already in simplest form and you can't factor it any further, just rewrite the question. Now, let's give you a different scenario here. It's not on the notes. I'm just going to add another problem. Let's say it was 4x. Let's modify number 7, put a plus sign. First glance, you're going to say, oh, wait a minute, she's trying to trick me. They're both perfect squares, but it's the sum. And you might think, oh, I can't factor this. But yes, you can. The only thing we would do here is pull out the GCF. So I could divide both of these by 4. And then this answer would be 4 and then x squared plus 25. I couldn't take it any further, but I can pull out a GCF. So even though the two terms are perfect squares, if it's an addition sign in between, and there's a GCF to pull out, you must pull that out. Let's try some more. Keep going. All right, Notice now I've got a power of 8. So just like we saw before, when we square rooted variables, we divide by the index. And when it's a square root, we're dividing it by 2. So let's go ahead and let me set up my binomials. And actually, let me move them up because this one's going to take a little bit of time. We're going to have to do it a bunch of times. All right, so the first thing I'm going to do is square root the first term, square root the second term. So that answer is going to go here and here, and then the square root of the last will go here and here. Again, one's a plus sign, one's a minus. So when I square root a variable, I'm just dividing it by the index. So a square root is a 2. So 8 divided by 2, and I get x to the 4th. Square root of 1 is 1. So I put in those into both binomials. But again, the difference is I'm putting a plus sign in one and a minus in the other. Now, again, once you factored it the first time, you need to double check, can I keep going? Now, my first binomial is done. I can't go any further with that, so I'm just going to rewrite it. However, my second binomial, I can keep going. Yes. So here, again, I'm going to square root this one, square root this one. So my two binomials, again, one with a plus sign, one with a minus. So the square root of x to the 4th is going to become x squared. Square root of 1 is 1 again. And then again, put in x squared here. Notice I'm still not done. I still have that last binomial that's still a perfect square. So again, the first two, because they're the sums, I can't do anything else with those. So let me rewrite those. X squared plus 1. This one, again, I can factor into x plus 1 and x minus 1. So again, the square root of this term goes there, and the square root of this one goes here. Now I'm finally finished. Same scenario is going to happen on the next one. Now I know I just mentioned to memorize the perfect squares up to 20. 625 is kind of a common one that you may see quite often. It's actually, when you square root 625, it's 25. So I'm going to go ahead and set up my binomials. One with a plus, one with a minus. And again, square root this term, square root this term. So that's going to go there and there and there and there. So the square root of 625 is 25. Square root of x to the 4th is going to be x squared. So 25, this is kind of tight, 25x squared plus the square root of 1 is 1. And then over here, 25x squared, and then put the 1. Again, notice I still have a perfect square, difference of two squares here on this one, so I got to keep going. So 25x squared plus 1 stays, but then this one, I square root the 25x squared, square root the 1, and then this becomes 5x plus 1. And 5x minus 1. And now I'm finally finished. Next one, at first glance, you might think, oh, 3 and 12, they're not perfect squares. What am I going to do here? But again, always, always, always look to see if you can divide by GCF first. And I can. My GCF here is 3. So I'm going to divide both of those by 3. And now I'm left with 1 minus 4x squared. Now I have the difference of two squares. It's written backwards, but I can still factor it. So again, I'll factor square root the first term, square root the second term. Again, don't forget about that GCF. Put it out front. Square root of 1 is 1. Square root of 4x squared is 2x. Put a plus sign in one, put a minus sign in the other. And I'm done. Number 12 looks a little strange. Next one is also still the difference of two perfect squares. So again, let's set up our binomials. So the first one, I'm going to square root the first term. Whenever you have a term that's being squared, a binomial squared, to square root it, it just cancels it. So the square root of x plus 2 squared is just x plus 2. So that's what I'm going to write here and here. And then now I'm going to square root the y squared. Again, remember one gets a plus sign, one's a minus. And then in here you're going to fill in a y and a y. And you're done. So for number 13, still the difference of two squares. So I'm going to square root this first term. Oops, let me fix this. So square root the first term, square root the second term. Let me set up my binomials. So the square root of x minus 1 squared is just x minus 1. Put in your plus sign, put in your minus sign, and then the square root of 9y to the fourth is going to be 3y squared. And I'm done. I can't factor any further, so I stop right there. No like terms to combine. All right, so for the next one, again, you might look at it and say, oh, 81's a perfect square, so is 36. But remember, always look for a GCF first. I can actually divide both of these by 9. So I'm going to divide them by the GCF first, which is 9. Write the GCF on the outside, then in the parentheses what you get after you divide. And again, I still have the difference of two squares in that parentheses. So now I can keep going. Square root, square root. So again, don't forget about your GCF. Square root of 9 is 3. Square root of 4x squared is 2x. And again, one gets a plus sign, one gets a minus. And you're done. Next one. Two perfect squares here. When you see those exponents on the variables are an even number, that's a perfect square. So again, I'm going to square root, no GCF here. So square root the first term, square root the last. Set up the two binomials. Square root of x to the fourth is x squared. You divide that power by 2. Square root of 16y squared is 4y. Put in the plus, put in the minus. Now, it may look like that second one is a perfect square. However, the y is not squared, so we would stop there. If we would have had originally a 16y to the fourth, then we would keep going. But I can't factor that any further, so I stop there. So that is all for the difference of two squares. Next, we're going to talk about factoring perfect square trinomials. And I know yesterday I told you whenever you have a binomial squared, and after you FOIL that, it turns into a perfect square trinomial. Now, not all of these, we have to test it first. And the way that we can test this is we're going to square root the first and the last term. And then if we double the product, if that equals the middle term, then all you have to do is square root the first and the last, take the sign from the middle, and you're going to square it. So let me show you what I mean by that. So to do the test on this problem, I would square root the first term, square root the last term, square root of x, squared is x. Square root of 25 is 5. And then now I need to double that. And if that gives me the middle term, then I know that it's a perfect square trinomial. And then to get my binomial, I just take the answer of the first term, answer of the last term, sign in the middle, and then I square the binomial. Or you can write it twice. Now, you can do this the traditional way where, and this is where we're going to be learning tomorrow, is when you look for the factors of 25 that are going to combine to give you the middle term. That's the other way you can do this. But again, if the first and the last term are perfect squares, do the test, see if it gives you the middle term. If it does, then you can just realize your answer is a binomial squared. If it does not give you the middle term, then you have to do it the longer way and look for the factors of the last term that give you the middle. So let's go ahead and try some more of these. So again, notice my first term is a perfect square, and so is my last. So I'm going to try my test. The square root of 16x squared is 4x. The square root of 9 is 3. I double that product. 4x times 3 is 12x times 2 is 24x, which is what I have in the middle. So this is a perfect square trinomial. So you just take the square root of the first term, square root of the last term, and then whatever sign's in the middle goes here, and then it's squared. Let's test the next one. Square root, square root. Let's do the test. Square root of 9x squared is 3x. Square root of 25 is 5. Double that. 3x times 5 is 15x, times 2 is 30x. It makes the number in the middle. So square root of the first term, square root of the last term, the sign in the middle, and then it's squared. 18, same thing. Square root the first term, square root the last term. Let's do the check. Square root of the first term is 2x. Square root of the last term is 1. Double it. It gives me the middle. So this is a perfect square trinomial. So write down the square root of the first term, square root of the last term, same sign that was in the middle, and it's squared. It doesn't always work. After you do this check, if this number was not what you saw in the middle, then we're going to have to resort to other factoring techniques. But in all the examples today, it's going to work. Chances are, I'll give you an example tomorrow where it won't give you the middle term, and we would have to look for other factors. These are all producing a binomial squared as our factored answer. And again, remember, when it's a binomial squared, it really means 2x plus 1 times 2x plus 1. You can always FOIL it. If this doesn't go back, then you've done something wrong. Let's try 2 more examples and we're done. Next one, I'm going to square root the first term, square root the last term, and then I'm going to double it. So square root of 36y squared is 6y. Square root of 49 is 7. I'm going to double it, and I get 84y, which is what's in the middle. So 6y, and then square root of 49 is 7, same sign that's in the middle, and it's squared. Last one now, this is a little typo. Add a v here in the middle term. Make that a 24 uv. All right, so let's try this one. Square root, square root. Square root of 9u squared is going to be 3u. Square root of 16v squared is 4v. Double it, and I get 24uv, which is the middle. So I can do the trick. So go ahead and same sign in the middle, and I get 4v, and it's a binomial squared. And I'm done.